Right, so I've got two complicated examples of functions where we have to find their derivatives using the definition of the derivative as a limit. So you could try to attempt these yourself and then compare them with my solution at the end, or gladly follow along. So find the derivative of f of x is equal to x over 2x minus 1 using the definition of the derivative as a limit. First step would always be to put the formula down so we have everything in front of us. So f prime at x is equal to the limit as h approaches 0 of f at x plus h minus f of x, all of that divided by h. Now let's get our plug-in straight. So we go back to our function, and wherever we see an x, we're going to put in an x plus h. So this would become x plus h over 2 multiplied by x plus h minus 1. This portion of our function has been inputted. Now we're on to the negative f of x. F of x would still be the function just as it is. So we're left with the following. The limit as h approaches 0, of course. And now we go into our basic calculus. I could try to subtract these fractions by taking a common denominator. So I'll multiply these denominator, and I'll be left with 2 times x plus h minus 1. All that multiplied by 2x minus 1. And that goes underneath. This multiplied by that, and that by that, cross multiplication. Should be pretty basic. Multiplied by 2x minus 1. All of that being subtracted from x multiplied by 2 times x plus h minus 1. All of that over h, and of course we're taking the limit. Now I see a chunk of variables and numbers in the numerator, so I'd like to expand this and hopefully find some numbers that cancel. So I'll be left with 2x squared minus x plus 2xh minus h minus, this looks like 2x squared minus 2xh plus x at the end, the negative and negative. All of that go over a denominator which I don't feel like I need to expand, although you could. 2x plus h minus 1 multiplied by 2x minus 1, all of that over h. And never forget the limit. So we're left with the numerator, and I can already see quite a few terms canceling. The 2x squared and the negative 2x squared go away. Negative x and the positive x go away. 2xh minus 2xh would give us a 0 again. And we're left with negative h divided by our denominator just as it was, divided by h. Now this is the same as writing the limit as h approaches 0 of negative h over 2x plus h minus 1 multiplied by 2x minus 1 being multiplied by 1 over h. Just taking that denominator and making it look like it's multiplication. I could cancel out these terms, and I'm left with the limit as h approaches 0 of negative 1 over 2x plus h minus 1 multiplied by 2x minus 1. And now I've happily removed the h from the numerator, and now if I plug in my limit, I won't get an indeterminate form. So let's plug in. We will have negative 1 over 2x plus h would give me just x plus 0 minus 1. That's the first bracket. And then 2x minus 1 will stay the same. This is equivalent to saying negative 1 over 2x minus 1 whole squared. And that is the derivative of x over 2x minus 1 by using the definition of derivatives as limit. On to a slightly more complicated example. So here I have f of x as a combination of functions. It's two separate functions. 1 over square root of 2x plus 3 plus 4 over x plus 1. And interestingly, we're being asked to find f prime at 3 specifically. So our x value has been given, which is 3. Always, again, start off with your function, limit as h approaches 0 of f of x plus h minus f of x, all of that over h. Now we go on to our plugins. Limit as h approaches 0. And wherever we see an x, we're going to put in an x plus h. But recall, we're given a value of x for f primed. So we're going to plug in 3 plus h for every x. That would leave us with 1 over square root of 2 times 3 plus h plus 3 plus 4 over, again, 3 plus h plus 1. Here we've completed this portion of the formula. Now on to the negative f of x minus f of x as it is. Again, we know our x has 3. So minus 1 over 2 times 3 plus 3 plus 4 over 3 plus 1. All of that over h. Now we could try to simplify our denominators here, and I'll do that in our next step. The limit as h approaches 0 of 1 over the square root of 9 plus 2h added to 4 over 4 plus h minus 1 over 6 plus 3 is 9. Hang on a second. Minus 1 over this is square root. Yeah, wow. Okay, so that makes sense. That's 1 over 3. Apologies. Plus just 1. 4 over 4 would become 1. And all of that is over an h. Now really, we could apply a very commonly used law of limits where we take the limit separately for different algebraic operations. In other words, I could take 1 over square root of 9 plus 2h subtracted by either one of these terms over h as a separate limit, and then 4 over 4 plus h minus either one of these terms divided by h and take the limit of that, and in the end I could add the two. So let's go about doing that. I'll take this with that and that with that. So I'll be left with, this would equal to the limit as h approaches 0 of 1 over square root of 9 plus 2h minus 1 over 3 over h, and then the limit plus, of course, as h approaches 0 of 4 over 4 plus h minus 1 divided by h. Now we'll deal with these separately. We'll start off with this half of the question. Over here we could see again there's simple subtraction going on in the numerator, so let's get that into one fraction to make our lives easier. So that would equal to the limit as h approaches 0. If we multiply the denominators, we're left with 3 square root 9 plus 2h. And if we add the numerators, we have 3 minus square root of 9 plus 2h. And all of that is being multiplied by 1 over h, which would equal to, of course, recall, we're only dealing with this half of the question for now. So 3 minus the square root of 9 plus 2h divided by 3h square root 9 plus 2h. And then we have really any numerator with a radical and a negative or a positive sign in front of it should by now give you an idea that it's a conjugate question. So we'll go ahead and multiply this by the conjugate of the numerator. So it'll be 3 plus the square root of 9 plus 2h divided by 3 plus the square root of 9 plus 2h again. And that would leave us with the limit as h approaches 0 of the numerator. 3 by 3 is 9, and that radical cancels. So the numerator would be 9 minus 9 plus 2h divided by the denominator, which I do not need to expand for now, multiplied by 3 plus square root of 9 plus 2h again. That would further equal to negative 2h divided by 3h square root of 9 plus 2h multiplied by 3 plus square root of 9 plus 2h. Of course, we haven't changed the denominator. Now what we can do over here is take the h's to cancel. We've achieved our goal, and now if we plug in our h equal to 0, we will not get an indeterminate form. So we'll do just that, and we'll be left with negative 2 over 3 square root 9 multiplied by 3 plus square root 9. This term becomes 0, that becomes 0. So that is equal to negative 1 over 27. We know the first half of our equation is negative 1 over 27. On to this part right here. So we have to take the limit as h approaches 0 of 4 over 4 plus h minus 1, all of that divided by h. And really, this is a simple one. We just try to subtract the numerators. So we'll have 4 plus h, and the numerators 4 minus 4 plus h. All of that over h. That further equals to 4 minus h over 4 plus h multiplied by 1 over h. And we're left with 4 minus 4, which is 0, negative h over 4 plus h multiplied by h. So we have negative 1 over 4 plus h, the limit as h approaches 0. That would equal to negative 1 over 4.